Good day, everyone. I'm Arvin S. Enriquez, your subject teacher in General Mathematics. With this video lesson, we're going to discuss the inverse of one-to-one functions under your General Mathematics from Quarter 1, Module 12. Our lesson objectives with this video lesson. At the end of this video lesson, you are expected to first determine the inverse of a one-to-one function. Second, write a letter to a family member or fear about making amends on regretful events which cannot be undone. Now let's talk about your inverse function. So the inverse of a function is a function with domain B and range A, given that the original function has domain A and range B. What does it mean? So if there is a given function, so whatever your x or your domain in your original function or x values, no, that will be your y values under your inverse function. It's the same thing. Whatever your range or y values from your original function, if you're asked to take the inverse of this original function, then simply whatever uh, your y values from this function, that will be your x values from for your inverse function. That's why it says here, no, that the inverse of a function is a function with domain B and range A, given that the original function has domain A and range B. So you're just simply taking the interchange, no, between your x and y values or your domain and range. So whatever your domain in the original function, that will be your range in your inverse function. So whatever your range in your original function, that will be your domain in your inverse function. So that's simple it is, no, on how we define your inverse function. Simply, there is a swapping of values between your domain and your range. So this inverse function of function f is denoted by f raised to negative 1. So we simply use this f raised to negative 1 to represent, no, your inverse function. It is defined by the equation f of negative 1 of y is equal to x. Simply, whatever your x here, whatever your x in your original function, that will be your y in your inverse function. In our original function, that will be f of x is equal to y. But in this case, that will be f raised to negative 1 of y is equal to x. So meaning to say, so whatever your domain in your original function, that will be your range in your inverse function. It's the same thing with the range of your original function to the domain of your inverse function. So we need to satisfy this one if and only if f of x is equal to y. So we can do this one, no? We can take the inverse of a function by simply checking, no, if your f of x is equal to y. Because if f of x is not equal to y, then we cannot move forward in looking for the inverse of this function. That's why only one-to-one function has an inverse function. Please do take note of that. Again, only one-to-one function has an inverse function. Then, let's continue with this one. So, for any y in range B. So, since both are functions, then a function must be one-to-one for its inverse to be a function at the same time. So, you need to look or you need to check if the given function is a one-to-one or not. Because if the function is not a one-to-one function, then you cannot take its inverse. Because only one-to-one function has an inverse function. And for us to make this inverse function, no, and to make this inverse, no, as a function at the same time. Because if that's not one-to-one, no, if we take the inverse of a function which is not one-to-one, then you cannot get the inverse of this function because only one-to-one function has an inverse function. So the inverse function is your inverse now of a one-to-one is still a function. But if not one-to-one function, if you're asked to take the inverse of not a one-to-one function, the resulting value or is not a function anymore. That's why one-to-one function has only one-to-one function, no, I mean, has an inverse function. If it is many-to-one function, its inverse is one-to-many, which is not a function. Yes, it is, no. Many-to-one relationship between your x and y variable can be a function. But again, the inverse of this one is one-to-many. Meaning to say that there is a repetition in your x values. So for example, if there's a given set of ordered pair, no, many to one, when we say many to one, there is no repetition in your x value. It's fine. That's how we define your function. As long that there is no repetition in your x value in the given set of ordered pair, that's a function. Now, if we take the inverse of this many-to-one function, you will arrive or you will come up with the one-to-many relationship between your x and y uh, variables, which is not a function because there is a repetition now in your x values. Because one-to-many, so meaning to say that there is only one value of x that can provide you two or more values of y, or one value of x can be factored to two or more values of y, meaning to say that there is a repetition, no, in your x values under this one-to-many relationship between your x and y variables. Therefore, this kind of inverse is not a function. That's why we really need to make sure before moving forward in getting an inverse of a function, we really need to check, no, if the given function is a one-to-one function. Because if not, then we cannot move forward in finding or in looking for the inverse function of the given function. Because only one-to-one function has an inverse function, no? And another thing is that if the x and y values, no, from our previous discussion, no, if the x and y values of a one-to-one function are interchanged, the result is a function. That's what I'm talking about, no? Even if you take the interchange between your x and y values, it's still your inverse of a one-to-one function is a function. Still, the resulting value is a function. Then next, if the x and y values, no, of a function that is not one-to-one are inverted, the result is no longer a function. Yes, because if you take the inverse of a many-to-one function, that will be a one-to-many. Therefore, it's no longer a function. So that's how we deal or that's how we define your inverse function. Again, only one-to-one function has an inverse function. So let's deal with this one. So how to find the inverse of a one-to-one function? So intuitively, the inverse of a function may be known by the principle of undo. That is, by considering the inverse of operations performed, the inverse of a function may be computed easily. So, in the light of the definition, no, the inverse of a one-to-one function can be interpreted, no, as the same function but in the opposite direction. That is, it is a function, no, from a y value back to its corresponding x value. So that's how we deal with how we find, no, the inverse of a one-to-one function. So for us to visualize more the process on how we get the inverse of a one-to-one function, let's deal with this example number 1. So here, there's a given f of x is equal to 3x minus 8. So the inverse of a function may be solved intuitively. So our solution. So let's deal with our solution. So your first step, no, in this process, so the last operation performed is subtraction. As you can see, no, in the given function, your last operation performed is subtraction. So the inverse operation of which is addition. So we just simply look for the inverse of the operation of the given functional, which is the last operation performed, which is your subtraction. So that will be your addition now. So the inverse operation of subtraction is addition. So we're going to apply this one. So to x, add 8. So we just simply, we add x plus 8. So we just simply uh, replace your subtraction, no, your operation between your x variable and your 8 by subtraction. Then by addition, I mean, no. Then for step number 2, the second to the last operation performed is multiplication. So the inverse operation of which is division. So as you can see here, your operation between your 3x is multiplication. So the inverse of this operation is division. That's why we need to divide this uh, x plus 8 by 3 for your step number 2. That's why it's x plus 8 over 3 here. Now, for step number 3, equate it to f raised to negative 1 of x to denote that it is the inverse. So meaning to say, whatever your resulting value in your step number 2, that will be your inverse function of the given, or the inverse function of the original function or the given function, no? From this example number 1. So the function of f of x is equal to 3x minus 8. So the inverse function of this f of x now is f of raised to negative 1 of x is equal to x plus 8 over 3. So that will be your first process, no, on how we get the inverse of a one-to-one function. So you need to check first, no. First thing to do is to check if the uh, given function is a one-to-one function, because you cannot move forward, no, in finding the inverse of this function if this given function is not a one-to-one function. Again, only one-to-one function as an inverse function. Next, for our second process on how we get the inverse of a one-to-one function, no. However, it is not easy in some case. Using our first process, no. In later examples, you will understand, no, what I mean by saying that there is more general method. So that will be our second method here that may be followed. So to find the inverse of a one-to-one function, consider the following. For letter A, express the function in the form of y is equal to f of x. From our previous discussion, I always said that we simply use y to replace, or that will be equal to your function. F of x, it can be f of x, r of x, p of x, q of x, r of x, no, u of x. Any letter, no, can represent a function as long that you know that this letter represents a function. There is no problem with that. No, we just simply use y to replace this f of x or any letters that we can use to represent a function. Now, interchange the x and y variable in the equation. So, for example, if there's a given function, no, we just simply swap or take the interchange, no, uh, between your x and y variables, or swapping of positions of your x and y variables. So we just simply replace all your variables, no, in your given function by simply putting, or by simply replacing it by using your x variable, and all x variable will be replaced by y variables. So it's vice versa, no. We just simply take the interchange or swapping of position of your x and y variables. And for the last step is to solve for the value of y in terms of x. So right after swapping of your x and y, no, variables, no, their positions, we just simply ask to solve for the value of y, no, in terms of x. So whatever the resulting value of these, no, if when we solve for the value of y in terms of x, that will be now your inverse function of your original function or given function. So for example number 2, if it exists, solve for the inverse of g of x is equal to x squared minus 6x minus 7. So if we try to replace, no, your g of x by simply putting y here, so we can rewrite this given function as y is equal to x squared minus 6x minus 7. So if that is the case, no, by simply looking with the given function or in the given equation, no, uh, it is a quadratic function. So it represents a parabola that opens upward. Why? Because if y, by simply observing, no, your given function, we can say that this given function represents a parabola, because by simply looking and by simply assessing your variables, no, if x squared is visible, no, in the given function and y squared uh, does not exist, no, in the given function, then we can say that this given function represents a parabola. It's the same thing, no. If y squared exists and your x squared does not exist in the given quadratic function, then it is a parabola. In this case, no, your parabola opens upward. Meaning to say, if we apply your vertical line here, vertical line, we consider this one as a function, because we satisfied your vertical line test, because there is only one point of intersection between your graph and your vertical line. How about once we apply your horizontal line? So once we apply your horizontal line test, so there are 2 points of intersections here between your horizontal line and your graph. So meaning to say, no, meaning to say, So once we apply your horizontal line test, no, there are 2 points of intersection between your graph and your horizontal line. That's why it is not a one-to-one function. So your n here is not, so not a one-to-one function. So we consider this given function as a function. Yes, it is a function, but not a one-to-one function. So simply this function, no, by simply observing, no, by simply observing your given function, and by simply graphing this function, no, we can identify if we can move forward with your inverse function. In this case, no, since this given function is not a one-to-one function, then there is no such thing that there is a value for inverse function for this given function. But with the solution, no, with the solution for your ano modules, no, it states here that recognize that g of x is a quadratic function whose graph is a parabola opening upward. Yes, it is opening upward. So it fails the horizontal line test because there are 2 points of intersection between your graph and your horizontal line test. Because it has x value which correspond to the same y value. So when you say one-to-one function, there is no repetition in your x values and your y values. Here, no, there is a repetition in your y values. That's why it is not a one-to-one function, or it fails the horizontal line test. And since it is not a one-to-one function, then its inverse is not a function. It's automatic, no? Once the function is not one-to-one function, then you're asked to find the inverse of this one. This inverse is not a function. Simply put, it has no inverse function. Yes, it is, no? Because only one-to-one function has an inverse function. So for alternative solution, no, let's apply now the three steps, no, in finding your inverse function. Let's try to prove, no, that there is no inverse function, no, that we can map on this given function. So first thing to do is to change g of x to y. So we simply use y here, no, to replace your g of x. Then interchange the x and y. So we swap, no, swapping of positions of your x and y variables. So all your x variable will be replaced by y. Same thing with your x will be replaced by your y variables. Then solve for y. We're asked to solve for y in terms of x now using the concept of your APE. APE now is the addition property of equality. Now, we simply, by solving your y variable, no, we just simply rearrange the given variables, no. We just simply put all your variables at the left side of your equation and all your x variable and constant to another side of your equation. Then, next thing to do is to apply the process of completing the square by APE, or the addition property of equality. Now, we just simply divide, we copy, no, we copy your first term, second term, then we divide this negative 6 by 2, that will be negative 2, negative 3, I mean, negative 6 divided by 2, it's negative 3, negative 3 square is equal to 9. Since we add 9, no, in this side of your equation, in your original equation, there's no such thing as plus 9 in your left side. That's why we really need to put plus 9 in your right side for us not to violate any rules in mathematics. Simplifying, so we copy your variable, then we copy your operation, subtraction, then we take the square root of 9, which is 3 now. That will be y minus 3 square. Then we simplify this one, x plus 7 plus 9. They are both positive, so we just simply add them. So that will be x plus 16. Now solve for y by factoring now. We just simply factor by factoring. Then we apply. So we take the square root of this y minus 3 is equal to plus or minus square root of x plus 16. plus or minus, because we don't know if that is positive or negative, so we consider both your negative and positive values for this square root. No? Solve for y by getting the square root of both sides. So that will be your second to the last step. Then next is solve for y by APE. So your y now is positive or minus, no? Positive or negative square root of x plus 16 plus 3. So notice that some values of x, there are two values of y. Yes, it is, no? For instance, if x is equal to 1, y is equal to square root of 17 plus 3, and y is equal to square root of 17 plus 3. So here, there's a negative sign here, no? It's a negative and positive value of square root of 17 plus 3. So therefore, the inverse function of g of x does not exist. So that's the reason, no, why if the given function is not a one-to-one function, there is no inverse function, because only one-to-one function has an inverse function. So you need to take note of that. So for example number 3, so find the inverse of the rational function h of x is equal to 4x plus 8 over your x minus 3. So first thing to do is to change h of x to y. So we just simply replace your function, no, h of x, by simply replacing it using your y. So it becomes y is equal to 4x plus 8 over x minus 3. Next step is to interchange x and y. So swapping a position of your x and y variables. So here, x now is equal to 4y plus 8 over your y minus 3. So we take the interchange of your x and y, or we just simply replace all your y values using your x. Same thing with your x, we just simply replace all your x value using your y values. Then the next thing to do is to apply your MPE, or the multiplication property of equality. So we just simply uh, cross multiply this y minus 3 to x. So it becomes x multiplied by y. It becomes x multiplied by negative 3. So it becomes negative 3x. Then we copy your numerator here. That will be your 4y plus 8. Then rearranging your given rearranging the variables now from this equation, applying your APE, or the addition property of equality. So rearranging, we just simply put all the terms with the involvement of your y variable, no, at the left side of this equation. Then the other variable to the other side of your equations. Now we can factor out y, since your first term here and your second term here, so there's an involvement of your y variables in both your first and second term. So that's why you can factor out y. Y now multiplied by x minus 4 is equal to 3x plus 8. So solve by factoring. So we apply your factoring. The next thing to do is to apply again your MPE, or the multiplication property of equality. So we just simply divide the entire equation, no, by x minus 4. So x minus 4 in the left side of your equation will be cancelled out. And 3x plus 8 over x minus 4 now is equal to y. Now, this portion now is your inverse function of the given rational function h of x. Now, we can rewrite this one as h raised to negative 1 of x is equal to 3x plus 8 over x minus 4. So this final answer is the inverse function of this given rational function here. Again, you need to check if the given function is a one-to-one function before moving forward. No. Because if that is not a one-to-one function, there is no such thing that this function has an inverse function. You need to check if this is a one-to-one function, then move forward in getting the inverse function of this given rational function. So for activity number 1 for this module 12, intuitively, give the inverse function of each of the following. Show your solution. You need to show your solution, not only your final answer. So here there's an f of x, g of x, h of x, f of x, and g of x. So there are 5 functions here. First thing to do is to check if the given functions are one-to-one functions. If not, then we can say that there is no inverse function for this given function. So if it is a one-to-one function, then we can solve for the inverse function for this given functions. So for activity number 2, it's an optional activity for you guys. If you don't want to deal with this one, then don't deal with this one. No. It's an optional. In real life, can we undo events? Definitely not. Definitely not. No. Have you experienced any conflict with your family or fear and concerns, like showing respect, being honest and trustworthy, or being helpful and cooperative? What do you do to make amends? No? So this time, try writing a letter to a family member or peer expressing your regret over an event. Pour out your heart and feel light up after then. So to make sure you will put smile on their faces, try scoring your letter using the rubric below. So let them to score you, no? So here is the description. If you got no, if you score your letter 7 or 8, proceed giving your letter wholeheartedly. If the score if the score you give is 6 or below, consider revising it, no, before giving it to your loved ones. This is a rare moment. Make it count. So again, this activity 2 is an optional. If you want to deal with this activity, then deal with it. Thanks for watching. So please like, comment, and subscribe.